Good morning, students. In the previous class I was explaining the advantages of an SVM. So that is the last part of the advantage of SVM states that it is in a non-linear curve. I can take an optimal decision on the non-linear curve, that is create a new dimensions such that the representation of the classifier is a linear function of those transformed dimensions. I think you have to recall here the scenario 4 and the scenario 5 of an SVM model when it was been shuffled and how it has been segregated, then how the solution has been taken by introducing in a function called as a z. Now the another advantage of this SVM is that they create a easy to understand the linear classifier by working on only in a subset of relevant data, that is they are computationally efficient. SVMs are now available with almost all the data analytics tool sets. Clear? So what I want to conclude here, once if we identify the gather the data, once if I gather the data, then I am going to train the data. Once if I train the data, then I'll identify it as in a TDM matrix. Once it comes under TDM matrix, then I'll apply an SVM such that it is easy for me to take an optimal decisions on either on the linear curve classifiers or if it is also in a non-linear curve classifiers. Clear? Now we'll move on to the drawback. Now that is in a disadvantages of an SVM. So the SVM has two major constraints. One is it works only with the real numbers, that is all the data points in all the dimension must be defined by a numerical values only. This is a major drawback. I will work on the real data and it should be converted in terms of a numerical values only. Why, my dear students, it is a numerical values? So once if it is a numerical values, then only I can segregate, then only I can get the weightage, then only I can get the future of the value, or I can say the value of the future of the support vector mechanism, or it is called as a model. Clear? So to do that, compulsory it should be in the numerical values only. This is the first condition of SVM. Without that we cannot go ahead. So that may be a drawback once if I gather the data. If I gather the data, if it is I am unable to convert into the numerical values, then I am unable to apply this SVM. So our main objective is whatever the data, whatever the source of data, whatever the ways you are collecting the data, we have to convert them by using some of the machine learning algorithms, or it may be using some of the techniques or the architecture tools and convert them into numerical values only. This is the only one major constraint of an SVM which can also be considered as a disadvantage. Clear? Now the second disadvantage, it works only within a binary classification problems. One can make a series of cascaded SVMs to get around this constraint. What all the problems are identified, those are binary classifications problems. So I think I'll explain this within one case study. Okay, how it has been taken care. Train the SVM is an inefficient and time-consuming process when the data is large. Yes, I think I explained you also in the previous classes. First of all, step 1 is of the algorithm says you gather the data. It may be in terms of a blogs or a Twitter, or it may be in a Facebook, or it may be an image, or however. So when we have collected the data, then our major task is to train the data. I told you apply repeatedly, you send that data for processing till they get trained, I told. So what I told, once if you are keep on taking the data and giving huge time, a large time for training itself, I think almost 70% of the data has to undergo for a training. So during that time only it is a very time consumes. If it consumes more time for a smaller period of data itself, imagine if it is in a large set of data. As we discussed in the module 1 also, big data talks about the petabytes. If it talks in the 10 to the power 15, if the data is in petabytes and 70% of the data has to undergo for a training, imagine how much time it will take. Understand? So this is one of the drawback of an SVM. Suppose if the data is large and it is inefficient and it consumes more time for processing itself. Clear? That is another drawback. Next drawback, it does not work well when there is a much noise in the data and thus has to compute soft margins. Clear? So as I told you in the first disadvantage of this itself is you can gather the data, you can collect the data. There are some data I am going to convert them into terms of numericals. I am going to convert them into a binary classification problems only it will take. So when I am converting the image, or it may be in a PDF, it may be in a Word, or it may be in a JPEG, it may be in any forms of types of formats of any data. When we are converting them into numericals, automatically it will not support. The data will have a 100% noise. So if there is a noise, automatically it will not work well. 170% times if you train the data, undergo for a training, automatically it will not support while compiling. That is, compute soft margins. Thus it has to compute a soft margin. That is one more drawback of an SVM. Next is SVM will also not provide a probability estimate of classification. That is the confidence level for classifying any instances. This I told you in the one example also in the previous class. Whenever we have taken, there are 6 products. Remember, like in a bread, butter, cookies, milk, egg was there. So then I have taken a 12 history, 12 summaries I have taken. In that also I told you support should be in a 33% and confidence should be in a 50%. So that is the target value. I have fixed it, I have assumed it, then I have calculated the problem statement. So what I want to say here, the probability estimation is not provided. I myself am assuming the target value. According to my target value, whether it has been reached or not, the data whatever I collected, I have trained, I have tested, I have evaluated, it has reached that target level or not. That is only my assumptions. Suppose if I do any wrong assumptions, instead of that I could have taken my support maybe in a 50% and my confidence is only 33%, then what is a scenario you can expect in the example? Automatically it will be exactly reverse. Clear? So what I want to conclude here, SVM will also not provide a probability estimate of classifications. That we are assuming, we are considering it, then we are undergoing for a processing. Clear? We are taking such data for a processing. So this is also one of the drawback of an SVM. Clear? So I'll just recall the SVM. Please, my dear students, it is a very, very important topic. Many times it has appeared in the video question paper. Please write thoroughly. So I'll just give one small survey. What is SVM? Support vector machine, and it is a supervised machine learning algorithm, and we have discussed about here how it has been sorted out, or what are the different ways. What is a scenario one says that, what is meant by a hyperplane, how it has been taken care, and similarly what is meant by a margin. Based on the margin I can pick the optimal hyperplane. So I think this is the ABC. In that ABC, which one is the best? I recommended by using a margin. Similarly, scenario 2, all the 3 are the best solution. In the 3, which is the optimal solution, hyperplanes. So then we discussed about the scenario 2. Then scenario 3, there will be some chances of shuffling. Then I told you outer layers it, you outer layers things to an axis, and then you sort it out whether it is near to the origin, whether it is away from the origin. So in this way I sorted out, and then I have classified within a function, and then we made it as a small SVM model, that is in a z is equal to x square plus y square, which just comes under the less than 0, which comes under the greater than 0, what all falls under equal to 0. Now how it has been taken care. Then we discussed about what is advantages and what is the disadvantage. So here also I want to share, I will share this notes also to you in the 5th model, where it has discussed about the 5 cases, that is about an SVM, how it works within a case 1, case 2 and case 3 and case 4 and case 5. Scenario 1, 2, 3 and 4 and 5, what type of decisions we have taken under the all the 5 cases. So how it has been by a classifier. So this is about the overview of an SVM model and what is meant by a right hyperplane by using cases.